think it said when there was 3 of pain med, that required 2 milliliters of water, right? Okay, so now I want 21. I'm going to make a mixture with 21 milliliters of pain med. Immediately you know, how much water do you need? Someone who said 14. What was your thinking? How did you quickly come up with 14? Yeah.
It keeps like the 3 to 2 ratio, but it's just like a multiple of that ratio.
So you're talking about two different things at once. So how did you get the number 14?
Like I kept so it was a 3 to 2 ratio, so 21 to something is still 3 to 2.
Okay, so you were thinking, all right, so we know med to water is 3 to 2, and so if I got 21, you're asking what value right there is going to maintain a 3 to 2 ratio. Which type of reasoning is that?
Constant ratio.
Constant ratio. So with constant ratio, make sure it's the ratio of how much of one quantity to the other. Okay, it's the ratio of one quantity to the other. So in this case, pain medication to water, constant ratio. So you just saw that 21. So someone thought of it a different way. So you came up with 14, but your brain did something different. Tell me. Yeah.
For the constant multiple, to get to 21, you multiply 3 by 7. So to get to, you multiply 2 by 7 also.
Since we multiplied, she's saying since we multiplied the pain medication by 7, to keep the right mixture, we got to multiply the water by 7 too. What kind of reasoning is that? Is that constant multiple reasoning? People are nodding. Yes? Constant multiple reasoning. Lots of people are nodding. So then what's the constant multiple? 7? What if can I do this? Can I say I want 30? Now what's my multiple that you're talking about? Did that 7 stay constant? No. That was not constant multiple reasoning. Because we can multiply this 3 milliliters of pain medicine by anything we want to get a new amount of pain medication. It's not a constant. So what is this?
Scaling.
This is scaling. Scaling is when you take one of the quantities and you magnify it or shrink it to get a new amount of that same quantity. Then you have to do the same thing to the other one. That's scaling factor reasoning. So that the times 7 there, that's scaling factor reasoning. What's my scaling factor now from 3 to 30? 10. How much water would I need? 20, right? What's my scaling factor now? 0.5 or 1/2. Therefore, how much water? 1. Okay? Can I scale the water? Sure. I just scaled the water. So now, how much did I scale the water by? What's that? 1/10. So now how much pain medication would I need? Scaling factor reasoning. Does it make sense? Okay, so then, but we mentioned, so I'll change the color. So in red here, we'll talk about the other one is constant multiple. What is constant multiple reasoning? What is it? Where in this situation do we see a constant multiple? What's that? The ratio that you have. Okay? So constant multiple is talking about what number would I multiply 3 by to get 2? What number would I multiply 3 by to get 2? So what do you do to 3? What do you multiply 3 by to get? Yeah, what was it? 2/3. I'm going to multiply 3 by 2/3 to get 2. And look at this. What do I multiply 30 by to get 20? Is it 2/3? Yep. What do I multiply 1.5 by to get 1? 2/3. What do I multiply the milliliters of pain medicine to get the corresponding milliliters of water? 2/3. So no matter what amount of pain med we have, to get the corresponding amount of water, it's always a constant 2/3. But a scaling factor, we can choose one quantity and scale it however we want. It's not a constant, right? We can take 1/10 of it, 1/2 of it, we can triple it, we can take 4 times the amount. It's just then we have whatever we choose for that scaling factor to keep the relationship, the other quantity has to have the same scale. You see? Okay, so what I want you to do is, I'm going to do a notebook check. You want me to do?
Well, I have a question about one of the questions, like the.
Okay.
So, like, what's the relevance of looking at how big the quantities are in comparison to each other? Does it just like?
So which of the, so talking about in part B, it's talking about relative size of the second quantity to the first, is that right?
Yeah.
So which of the three would be related to that? Relative size of the second to the first. Would that be like constant ratio, scaling factor, or constant multiple? The relative size of second quantity to the first, the relative size. What's the relative size of water to pain medication? What's its relative size? It's always no cross multiplication. Okay? Okay, here's when you can do cross multiplication. When you set up constant ratio and you understand, you talk through what that means. And then it's too hard. Like this one was really easy to see that's 14 without doing any calculation, right? But if the numbers are too hard and you're using constant ratio, that's when you can cross multiply. But that's only part of one of the 3 ways of reasoning. Okay? So yes, without cross multiplying, what is the relative size of the amount of water to the amount of pain medication? The amount of water is always what size relative to the pain medication? Yeah.
So for 2, whatever, quantities to be proportionally related, do all 3 of these things have to be applied?
Yes. If you have proportional quantities, well, it will be all 3. If one of them holds, then all 3 will hold. Okay, now, back to my question. What is the relative size of the amount of water to the amount of pain medication?
2/3.
2/3. The amount of water is always 2/3 of the pain medication. That's its relative size. Relative to the amount of pain medication, the water is 2/3 of it. So it's asking about relative size. What's it asking about?
Constant ratio.
Yeah, it's really asking about the constant multiple. A constant multiple is that relative size of the second relative to the first. Okay, is there one of the tables you want me to talk about specifically? Yes, ma'am. The second one? Table 2, is that what you mean? Oh, no, in number 4, the 3 tables in number 4, since most people have thought about those. Yeah.
No, I was going to ask about the difference between constant ratio.
Okay.
Could you talk about 3 of it? The third table?
What's that?
The third table?
Third table. So I'm going to, can I take, let's see. I'm going to erase the screen. Okay, so, wow, this room. So just tell me, can you tell me what the numbers are? Negative 3.1 and 1.93? 0.5. 1.43. 1. So if we're testing to see if these represent two quantities that are proportional, so this is quantity 1, quantity 2. And we're testing to see if they're proportional. You can use any of the three ways to test. So, who asked for it? Who's asking? Which way do you want to use to test?
Constant multiple.
Constant multiple. So what is constant multiple about? It's about what number would we multiply a quantity 1 by to get the corresponding quantity 2. So how about, here's the easiest one right here. Let's look in the third row. If constant multiple of pi, and we're looking at this third row here, what would the constant multiple be? It's so easy, right? We're asking what number multiplied by 1 gives us 1.85? 1.85. So, if these are proportional quantities, what would have to be true about these two pairs? So what would have to be true if we got proportional quantities? Say the second row.
Anything in Q1 would have to be multiplied by 1.85 and equal that Q2.
That's right. So the question is 0.5 times 1.85 1.43? No. So we're asking, question. Does that work? It doesn't work. So we can, as soon as that doesn't work, you can stop. You don't have to try another one. You don't have to use a different type of reasoning. As soon as that doesn't work, they're not proportional, because if you have proportional reasoning, what kind of multiple do you have? Constant multiple. So all of them would have to be 1.85 times, all Q2 would have to be 1.85 times this corresponding value of Q1. Does that help?
Not really. I just wanted to know if you could actually have a ratio with a negative number. Or is that against the rule?
Okay, so sure, you can have a ratio with negative. Just as long as those rules apply.
All the numbers would have to be.
Yeah,
on
so
one side, though, right?
yeah, all of them on one quantity would have to be negative, so that all our rules, so all that our reasoning would still hold. But yeah, you can have negatives in these tables and have proportionality. Yeah, you can. Okay, so that's what you're doing for each of those tables. Then similarly, you're working through on number 3. So let's keep going. Let's try rows 2 and 3, and can.
For 3B, I don't want to keep saying like there is or there isn't a constant multiple as a justification.
3B.
Yeah.
Let's do it. Which one is it? So it's
Cable company.
price of or number of months. Is that right?
Yeah, it's the number of months is proportional to the accumulated cost kind of cable. I mean, like, I understand how to find it. I just don't want to keep saying, oh, well, it does or it doesn't have a constant multiple.
Yeah, let's do it. Okay, so total cost for.
So what I did is I set up an equation. So 36x plus 75 equals the total cost per month. So like for 1 month, the total cost is $111.
Okay, let's do 3B. Let's do 3B. Okay, 3B was. Wow. There you go. The technology curse in this classroom. Okay, so number 3B was the first quantity was number of months. Second quantity, total cost for that number of months. Right? So let's just set up a table and we'll analyze the table. So make it easy on yourself. Don't choose something difficult like 17 months and try to make it. All we have to do is just enough so that we can know whether they're proportional or not. So what's the number of months that will make it easy for us just to know the total cost? 1. What's the total cost after 1 month? How much? 111, because there's a $75 startup plus the first month. All right, there's an even easier one. Okay, we can do 2 months. How much will it cost at 2 months? 147. Is that right? Okay. Let's do one more. So after 3 months, how much does your cable cost? 183. Does everyone see where these numbers come from? There's always a $75, and then you're paying how much per month? 36 per month. So you've got the 75, and then if it's 2 months, you're going to have plus 2 36s, right? And then if it's 3 months, you're going to have the 75 plus 3 36s. That's where this comes from. Okay? Make sense? So proportional or not. So we did I think we did, let's do scaling factor. How can we use scaling factor reasoning to check this?
How do you multiply 1 to get to 2?
Yeah, exactly.
It should be the same for 111 to 47.
What do you multiply 1 by to get 2? That's doubling the number of months. If it's proportional, what should happen? You should have double the cost. Yes or no? Does your cost double? No. If you triple the cost, triple the number of months, what should happen? It should triple. So we should pay how much? 333, but we're paying 183. That's just another proof. But this is enough. As soon as you have one example where scaling factor doesn't work, they're not proportional quantities. Questions about this example? Okay, let's do top hat. Put your internet.